All right, welcome back. We are Game 3001. That's Artificial Intelligence for Games in the winter 2022 semester at George Brown, and it's week 3, part 3 of our broadcast and recording. And why are we doing a third part? Because the last part didn't quite work out. We're going to fix those problems and make sure everything is good. Sometimes it takes a little bit of finagling. I'm not sure how long this is going to last. But sometimes, when you write yourself in a corner, you got to write yourself out one. So let's see how it goes. So where we last left off, we had this issue. The issue was we were trying to use, or I was trying to use, the kinematic equation for motion, which is pretty cool. And what I did was I said, hey, let's add acceleration here at the end. And really when I thought about this afterwards, I was like, I really don't have to update my velocity, right? I'm just going to add my acceleration over time. So this is the thing that's going to influence everything, the acceleration. The problem with this, right, is again, we only set the current direction the first time, right? So going back to, I'm just talking this out with you guys now for people who are watching, but let's go back to what we did. So originally what we did was we set the current direction and then we just added, once we had the current direction, we had a vector. And then all we do is we just kept on adding speed to it, right? We're adding acceleration every frame, right? So we don't keep adding this. This is added once, right, as an example. And then what we do is we modify what we're going to get from our velocity with acceleration. So theoretically, what we should be able to do is, instead of what I was trying to do with both acceleration and velocity, I think just acceleration will do just fine. Right, so what we want to do is change the acceleration to whatever the current direction is, right? Because we're going to change our current direction, right? Because we're going to set the current direction to whatever that target direction is going to be. And I kind of did everything here. I said the desired velocity was kind of how we broke things down here. That desired velocity is a normalized value between with a unit length of 1. So I was kind of good with what I was doing, which is I kind of broke it down further like this. I said, my desired velocity is cool. And then our target direction is like my desired velocity, right, minus my current direction. So again, if I'm looking at a particular angle and then I have to go over here, then I have that steering. That's what's happened. That's what this is. This is the steering piece. So target direction or steering is this piece. And then what I want to do is set current direction to whatever the steering direction is going to be, or target direction. So it doesn't matter if we call it target direction or steering, that's how it is. But I really would like to use set desired velocity because that's something that is kind of all-inclusive. So we could probably do something like this. We could say something like, let's set the desired velocity, right? And we pass in, like we did before, our target target direction. So, get target direction we put in there. Our target position. So that gives us, that would return our M desired velocity is going to be something that is going to be, kind of saved. So we save desired velocity. Now, what I can do is I can use that desired velocity because we already have it. This desired velocity is really what we did up to here. This is this part. So target direction, we just have to not do this anymore because we already have a function for that. And we can say that we can even call this steering, steering direction, which is just, let's put the word steering in there. Why not? Steering direction, right, is equal to, instead of this minus this, we can just say, let's take our M underscore desired velocity. We can also use the get desired velocity. That's also something we can do. Minus the current direction. Both current direction and our desired velocity are both unit vectors, right? So again, we have a unit vector. We have another unit vector. We'll get a unit vector out. Again, that's the idea behind it. And then once we take that steering direction, and we set the current direction to that steering direction this round or this frame. And it says that when I look here, it says you probably can make this const. And I think that's pretty cool. And some people didn't like the fact that I was using autos. Let's use GLMVec2. And that gives us our steering direction. And what we can do is we can take that steering direction, set the current direction, then once I get the current direction, multiply it by my acceleration rate, set the acceleration to that. And that's the only thing that would change. The speed wouldn't change, right? Because speed would be something that is constant. And really, if you think about it, what I was doing here back in the plane, right, where I said, like, let's take my current direction for the velocity and add a speed, that's actually incorrect. The max speed, if you think about it, will be our speed limit. So if I did something like this will make it really slow to start, right? So we start off, and the acceleration is the thing that we want to add in. So the acceleration. And then once the acceleration accelerates, then the velocity will keep going, right? So I could set an initial velocity of something, but remember, if we're going to go at max speed, we're actually doing things kinematically and not dynamically. Dynamically, we accelerate and decelerate. So really what we're doing is just accelerating. So adding acceleration, but we don't add max speed here. Just to, as a thing, right? So all we're doing is we're monkeying with acceleration then, positive or negative. Just to fix some of this stuff, we know that it's going to be the same thing. So if I change my target position, right, then we definitely want to set my target position to something new. This will be in play. This is good from an IMGUI perspective. Velocity, when I want to change my maximum speed, all I'm doing instead of doing this is I'm clamping, all right? So maximum speed will just clamp everything. And so I don't have to do this here. And that's exactly what I want to do with my speed of my ship. So when I start moving, as an example, I will have my velocity. But what I want to do here is let's add my acceleration. But then what I want to do is clamp. And I want to say something like get rigid body, right? So I can accelerate to my maximum velocity. I can say that my velocity, right, is equal to and again, there's a couple ways to clamp. One of the things I've created is a util clamp, and it takes basically a couple of values. If I open it up, it says I have there's two options actually. There's two overloads. One of them is it takes a value and it goes between min and max. The other one is it takes a vector and it goes between, for max length. So that's what we can do. We can say that the maximum speed is the maximum length or magnitude of the vector. So we can say that let's take get rigid body dot velocity, and we can clamp it with max speed, get max speed. That's what we want to do. So this way it's truly a speed limit. It's not going to go and go and go forever. Otherwise, the way we had it before, it was going to keep increasing to infinity. And that's not really what we want to do. So this will clamp our velocity at max speed, right? So that means it won't allow you to, go faster than max speed. We want to also add, our acceleration to velocity every frame. So that's going to increase our speed. And what this thing is going to do, our final position, is going to give us an initial movement, if you will. This is going to move us. And that's what this position vector is going to do, right? So final position is going to be equal to this velocity measure. Now let's see if we need to scale this and see if this actually works. So this is the seek algorithm. Seek is done here, and all seek does is change the velocity vector. That's all it really does. It changes it so that we move in a different direction. We accelerate in a different direction. Okay. All right, let's run this thing and see if it's the same way we thought it's going to be. And there's some other changes we have to make too. All right, cool. So again, just like before, we launch it and let's, kind of toggle seek, and that's what I wanted to see. So it kind of goes forever. All right, good. It's better. It's a better result and it's a smoother result. But what happened? How come I went straight up there? Because again, my acceleration is pretty low, right? Let's try it again. And we'll launch it this time and we'll increase the acceleration value. The max speed is the speed limit, if you will, right? So if I clamp my max speed to 5, that means it can never go beyond 5. So I can increase this. We'll say 20 is the maximum we can go, 20, right? something like a 20 value. And then instead of 2, let's increase that to 5. So we want to increase one increment by 5. We're going to quickly get to 20. And so far we haven't touched about turn rate. Let's talk about that and see what happens. Now that's a little better, right? So it kind of goes right up to there and everything else. But what happened to the forward momentum? Because it didn't really do anything. And now that's a problem too. What that's doing is it's flashing between one position and the other. That's a bit of an error. So we're still got a bit of an issue with movement. All right. Let's try one more time. And let's see if we can change the numbers to make sense. So again, I also want a reset button, and the reset button will reset our object somewhere else. Let's also move just by chance, let's move this thing so it's way over here for now and see what happens, right? So if I toggle seek the way it is, you can see it's going to just make a straight line to the thing. It doesn't care about, orientation or anything like that, right? So again, so when it comes to seek is working because it's going in the direction that it wants to do. Again, but maximum speed means something different than it did before, okay? Let's bump acceleration up a lot. So something like, like 20. If we set the acceleration rate to 20, or even make it something that's more reasonable, like 5, but make my max speed. So if we increase by 5 or 6 and then make my max speed something like 30, that means we can accelerate up to 30 every frame. And let's also move this over here. And let's see what happens if I do this now. And there you go. That's what we want to see. We want to see that motion where kind of it goes like this, right? Where it kind of flashes and it keeps on overshooting. That is exactly what we're looking for when it comes to the motion for our that we're looking for seek. And the reason why it's turning around like that is it's trying to find the place where it's going to stop. That's what it's trying to do. So very good. That's what we're looking for. And that's what it should do with seek. Okay, it accelerates. It accelerated at 5. It has a max, that's a top speed of 30, right? That's pretty good. If I lower my top speed, I'll clamp right down to this. If I increase my top speed and I increase my acceleration, all that's going to do is going to make it go crazy like this. There's going to come a time where, again, what's going to happen is this flashing effect is trying to be, it's so fast. So this has to come really much, much closer to be down, where I can really reduce this right down to 0. If I kind of put this down here, then it's 0. I can increase my acceleration. But once I do that without maximum speed, let's say, for example, I want to put maximum speed to 24, and I start accelerating. The reason why it's doing this is because there's some additional values that are stored that we have to take care of. So we still have some problems, but it's a little better, little better. Okay, a little better at a time. Okay, so let's start scaling now. So let's see how the scaling function works. So if I add delta time in here, and I talked about adding delta time once for both acceleration and velocity, this will help us scale it even more and prevent perhaps some of that weird flashing thing that happened. Okay, so again, if I just turn it on the way it is, let's see what happens with that. So it's really slow. So again, 2 acceleration per frame, it's pretty slow. If I can increase this to something like 40, it's going to stop in the dying now, watch. And the reason why is because it's so slow, right, that we're just right around there. So it's not going to flash as much, right? But that's what delta time does, is it really scales it back, like 0.16. So acceleration of 2, that's 2 pixels per unit, per frame, is pretty slow, and that's scaled acceleration. So that unit 2 is low, right? Let's try it again. Again, I know I'm jonesing for a reset. Actually, let's just build a reset right now. Okay, how does that look? So again, if I go back to my placing, we want a reset button somewhere. And it's going to be a button where, and what will reset do? That's another thing we have to think about. So one thing to note is this is good. So this acceleration thing is working nice. Max speed is a clamping. Toggle seek turns off and on this thing, but we want a reset button. That's what we want. So let's put a reset button at the bottom. And remember how buttons work. We can say that I am GUI, and we can look at a button. We can call that button something, like, for example, reset. If it's pressed, that's how easy buttons are. Then what do we want to do? First, we can change the ship's location and do a lot of this, actually. This is kind of like a reset function, right? where I can do all this. I can set back my ship to something. I can change my current heading back to what it's going to be, you know, that kind of thing, and all those kind of things as well, right? So I can reset everything back to where the ship is going to start. And I can also reset not just my ship, but also my my enemy, my target. And I'll talk about how to put my target into play as well. So all of this is something that we want to add in to the reset function. So something like I want to set my target position to the new position. This is something we want to do. And at the same time, we also want to change the velocity to the current direction. We can set velocities back to 0 and all those kind of things as well. So let's do all this first. So grab all this and put that, let's start with this part right here. So again, we can say, okay, spaceship, set current heading to 0. So we're going to make basically face to the right. Set my target position to whatever the position is of the object. And we can also set the spaceship's position. So we can say m_p spaceship. Let's set that get transform dot position. Let's set that back to the left side of the screen. And again, I'll probably make it the bottom left. So let's say something like 100, and where we started off with the spaceship before. Notice I said in the spaceship, we did this inside of the constructor function where I have like 100 and 400. So I think I can just grab a lot of this and go back to here and then just put that over here. We can kind of get rid of this. There we go. So that is the position that's going to start in. I really think that the position of the target should be different. So if I go back to the target position, and that is the game object that is target. Let's go there just for a second. Target CPP. We started off at 100, 100. I think probably 100 and is probably too low. Let's put this at 100 position here is okay. That's the y-axis. That's kind of the top part of the screen. But we should probably put this at something like 500 to start off. Right, so something on the top right corner. This one will start at the bottom left corner, right? Okay, that's something that we want to do. All right, so that's good. That's excellent. And we also have a move for the target, but we don't need to use anything like this. Notice it says, let's add position and add velocity position multiplied by 5. We're going to get rid of that because we're not going to do any moving target right now. So right now the target is pretty much just there for the move. I just added the target, but I can modify it later. All right, so again, not much going on here in terms of my target. I just wanted to reset it so that when I'm moving the ship, it starts off at a new position. So that's good. So 100, and like we said, something like 500. Again, let's go back to the target. We set this right here, 500 and 100. Let's grab this and set the target there as well when we reset. So again, going back to here, I'm going to say, okay, so we reset the position of the ship, reset ship's position, and we'll do the same thing with the target, reset target's position. We want to total do a reset, right? And we're going to say, again, I'm going to grab that code. And then go m_p target. Set that. So that's the target position. Nice, nice, right? So we reset the target, we reset the ship, we reset the way the ship is looking. This is important. Get current heading, right? And set current heading to 0 changes a bunch of little things. Set target position. That's going to be the new target, wherever we put it now. So it's going to reset the target position to there. Set rigid body to the get current position. That's the velocity. So when we do this, the spaceship get current direction. That is when I set the direction to the target that I'm looking at. And actually, really, this shouldn't be this way. This should be 0. So this is also incorrect. So velocity, we're going to take that out. We're even going to remove that from here, because what this does is it already starts looking in that direction, and we don't want it to look in that direction. We want to start looking towards the right. If we change the velocity, then our current direction is automatically changed so it looks at the ship. We don't want that. We want to look to the right first. And so we don't want to set it there. And in the spaceship.cpp, if I scroll up, we do have that velocity as 0. So this is good. And these values are actually a good thing to do. Velocity is 0, acceleration is 0. I want to start these two things at 0, 0, and then start adding velocity and acceleration like it's starting over again. Okay, so let's go back to this. Because this is a reset function, we can do that kind of stuff. So let's go here. And so we say, okay, cool. So we first we set the current heading, and we have the target position. And then what we want to do is our acceleration is going to be this, but we also want to set the velocity to 0. So we want to kind of reduce the velocity back down to 0, right? So that there's no direction that we're getting at until we get it from the acceleration. Okay, so this is where it's going to go. So again, I want to kind of grab this piece, right? So set spaceship and rigid body, velocity set to 0. Now, what does this do? It says the acceleration, we want to get current direction, and we want to multiply the acceleration rate. This is good. It's not going to be setting it on the target position. That we want to do this theoretically after everything else, something like this. So this resets our velocity and acceleration and our current heading. So reset current heading, orientation, velocity, and acceleration. That's what we're doing. We're resetting all those things too. And then finally, we're setting up the target position. Where do we want to go, right, for seek? Because that's what we're doing with this seek algorithm right here. Okay, cool. So that's what it does. And I think this might be pretty good. We might have found even a bug here in the start method when we had velocity equal to the, where we're looking, right? Okay. Although I have to tell you that get current direction might not be a bad thing to set the velocity in, but that means that we're always going to have a little bit of speed, right? And we don't want that. We want to start at 0 and then have our acceleration drag us around. That's the right way to do it. Okay. Let's do one more check, cursory check, and see how this works. So going back to our kinematic formula then, when we look at it, we're like, okay, so we start off and we say that the desired velocity, set the desired velocity and the current speed. And we're going to say that the steering direction is equal to the desired velocity where we want to go and the current direction minus the current direction. And then we're going to set the current direction to the steering direction. That's what we're going to do. That's the current direction we want to go in. And this set current direction to the steering direction is all or nothing. This is where we're going to kind of change our direction. And we want to do this gradually. This is instantly. Okay, this is what's happening. It's instantly changing our seek. And that's why it looks the way it does. It doesn't go in the direction we're going. We should be changing the current direction according to our turn rate. We haven't used turn rate yet. We will. And we're going to use turn rate here too with Look Where You're Going. All right, let's try this thing out and see how it looks now. And does it work better? Do I see a button? Did I mess up? How does it look? Okay, so there it is. There's my reset button. And I can click that, no problem. And if I press target, then we should see some motion as it moves towards this. If I increase my top speed, let's say move it to 20, and move my acceleration to 5, then we should see some motion as it goes kind of towards this target. Slowly, slowly. And if I click reset, then it's back to this, and I can try, moving the max speed higher and moving my acceleration higher. And reset again. Okay. So these things don't seem to be as effective anymore, and I think it has to do with our scaling. But the great thing is it does this, which means it's kind of going, and this is bad. This thing that's jumping around is because we're getting to the point where it's trying to go back and forth. Okay. Taking away our scaling again. I think, again, I found more success by not scaling than by scaling, right? Because we're already scaled once, like I said. So doing that again probably isn't the right thing to do. Let's take a look. So again, toggle seek, and nice. I reset, increase. There we go. I can toggle seek off, reset, right? And let's move our acceleration higher, let's say to 10, and then toggle seek, right? And I reset, does the exact same thing. I can increase my acceleration and reset. And this is where it gets a little funky because my acceleration rate is higher than my max speed. Okay, and so I can increase that max speed to something great and reset. Doesn't look bad. Doesn't look bad at all. So that is generally what seek should look like. It's going to keep doing this over and over again, right? And it's got a nice arc. And if I move this thing around, it should move with it, right? But until we get to the point where, right, it's over here, and if I move it over here, you can see it follows exactly. And that's an issue, right? So again, if I move it over there, you can see that it circles, it orbits, right? If I move it over there, it orbits. And if I move it over there, it orbits because it's really, really fast, right? Let's toggle that off. Let's reduce the speed to something normal like 25. Again, we're kind of trying to break it in some ways, right? We're kind of saying, let's see what this looks like when we reset. Also, other things. We didn't reset our max speed, our acceleration, and our turn rate, and that's okay. These things reset, but not these things, because that would be like, okay, now I got to reset everything back to what I had, right? So let's try moving this down here, and maybe a little bit higher up, like this, and go. See what? Oh, let's try that again. There we go, and go. So it kind of went that way and then kind of went down to here, right? And then what happens if I move it up, right? And you can see it gets lost, right? And if I reduce this right down, so we reduce this right down there, and I increase, as long as I increase the max speed, then it comes to the point where it does that flashing. This flashing effect, the reason why it's happening this way is because it's going so fast because of my maximum speed. If I go to here, right, so I drop max speed down to 0, right, and if I increase it a little bit, let's say to 10, and I start accelerating really slowly again, then theoretically we might be able to get back to where we are, right? Let's reset, and there we go, back again. You can see that that is okay. Low acceleration, high max speed gives me a kind of a really big motion, right? Reset. Reset. Let's move our max speed down to something like 15. So I think the reset function really helps a lot to see what it is. So low acceleration, high max speed, higher max speed, and toggle on. Again, pretty good. But kind of goes directly in there again. Doesn't go forward, doesn't look where you're going. All right, so how do we implement then look where you're going? Well, first things first, right? So seek is pretty much good, right? For the most part. It's got some issues, but that's just normal. And it's normal because of the values we're allowed to put in. One thing I'd like to do is start off with values that make more sense. So that's one thing I'd like to do before I put this up on GitHub. So in my planes, my ships, my spaceships dot kind of starting where I have 5 for speed and turn rate is 5 and acceleration is 2. Let's make our max speed higher. Let's put something like 20 to start off with. Acceleration for something like 4 might be okay. I think that's a good amount. We don't know about turn rate yet because we haven't used it. All right, let's put this up on, first let's try it as a good step. Right? And yeah, that's pretty good. And this is actually what we're looking for. Nice. It's nice and smooth, motion and everything else. That smooth motion is because of our kinematic equation. And it exactly took the values that we took, and that's kind of the thing that we wanted. One thing I don't like is this, how it kind of follows exactly. That exact follow is actually not right because it's not looking where you're going, which is what we're going to do next. All right, so let's put this up on GitHub. Again, I'm going to use the GitHub desktop. I'm going to pull that up. And we're going to say that we've fixed bug with seek, which is what we did. And we're going to push that up. There's that one. And now let's do the look where you're going thing. And the look where you're going thing is interesting in that we got to think about how we're going to implement that, right? How do you implement look where you're going? Okay, and this again, what you want to think about more than anything else when you do the look where you're going algorithm is what your aim is. You want this thing to have thrust. We talked about this last time, so I'm just gonna go back to this, right? So imagine if I have a ship, and I'm just gonna draw a simple ship again. And let's erase some of this because we were talking about some of this stuff here, which was classes and objects and stuff. And what I'm going to do is I'm just going to kind of erase this one, and we'll make that a much larger eraser so that we don't go too crazy. But that allows us to eases up some space with what we want here. Okay, cool. So yeah. And let's go back to this. So now what I want to think about is when I'm drawing, and let's draw a spaceship again. We'll draw a little triangle. So imagine if this seeker is our spaceship, but we want to draw a line that goes like this for the back. And we want to kind of draw the front. It's kind of like this. Okay, so there's our front. There we go. So there's our front of our ship. And we're going to have thrust that goes kind of behind us like this. So you have some kind of thrust where the ship is moving this way. If there's this kind of thrust, right, then what's going to end up happening is it's going to move in this direction, and then it's going to have a turn rate. So that turn rate is going to influence how fast we can, kind of look in the direction we want to go. That is what we want to accomplish with look where you're going. So we have a thrust. Okay, cool. So that's one thing that we want to do. And so that's the first piece. The first piece is all around how does it look? How does it look when it comes to to doing that motion? The ship moving around and all that kind of stuff. And how does the look where you're going thing work with the spaceship? Okay, so that's the thing that we want to kind of connect with, right? And the look where you're going things on the spaceship is kind of down here next to we haven't really addressed it yet. And it's going to be, we have to modify a couple things. This set current direction. I mean, that's one thing. We want to definitely incorporate look where you're going in here. So when we're seeking, right, when the starship is seeking, instead of doing our acceleration and the current direction. This is good. I like this. But right in here is where we're going to implement look where you're going. So before we set the current direction, right, instead of setting the current direction here, then we want to use look where you're going in order for us to do that. Okay. So what we want to set up before we do anything with that other function, we want to set up a target. So let's say, for example, we have a target, which is a rotation. Let's call this auto. And we'll call this the target rotation. So where we want to look at. And that's going to be really equal to our util signed angle. All right. And we're going to get the current direction. Get current direction. So we're looking at a specific spot, right, where we have a target direction. What is that target direction, right? So target direction. Okay, that's where we want to go. So we want to kind of go with a, the current direction and the target direction. For the target direction, let's add a variable here. So we'll say GLM vec2. We'll call this target direction, and we'll modify the our declaration inside of the spaceship.h to do that. So again, inside of look where we're going, we'll say we're going to have a GLM vec2 object, which is the target direction. We're going to pass that into the function. Okay. And so that way here, when we pass it into the function, we're going to use this value. We can declare this as const. We can use this value so that way when the object is passed in, the target direction, we can get our target rotation from the signed angle. So signed angle, let's take a look and see what that does for a second. Go to definition, right? Here's our signed angle for in the util function. It takes two things, a from vector and a to, from one vector to another angle, to the other two. And it basically says we can use the angle and we can get the absolute value of that. So there's actually another function called angle, and we're actually wrapping the angle function into something called unsigned angle, right? So that's what it is. So we get the angle first. This is an unsigned angle, right? And we get it from to, and we're going to get an unsigned version. We're going to use the arc cosine, and we're going to clamp, use the dot product, and we're going to normalize. Look at all this crazy stuff. We're going to normalize from, and we're going to normalize to, and we're going to get the dot product from -1 to 1. That's what's going to happen. We're going to clamp it from -1 to 1, and we're going to multiply by 57, which is like a deg to rad equivalent. Okay, that's what we're going to do here. Phew, right? Or rad to deg actually is what this is. So we're going to convert it back into degrees. That's the angle that we're going to get, the unsigned angle. Then what we want to do is we want to say that let's convert, get the sign, right? And we're going to go from x multiply 2y minus from y to x, and we're going to get the sign of the angle, a positive or negative sign. And we're going to return that angle or the signed angle back out. We're going to take the sign, multiply it by the angle, and whatever that sign is, positive or negative, it's either going to return a positive or -1. That's what sign does, right? And again, if you look at sign, util sign, go to definition. Util sign basically says, okay, use the ternary operator, get a value, and if the value is less than 0, then return -1. If the value otherwise, return 1. You can't have a sign of 0, so it's either -1 or 1. That's what you're going to get back with the sign. So you're going to get a -1 to 1, one of those values, and you're going to multiply it by your unsigned angle, whatever that happens to be, and then you're going to have your signed angle. And that's what we're getting when we use this value, when we use this this formula here. So signed angle from our current direction to our target direction. That is the angle we want to go to. Cool. And then if we look at the auto, for those people who hate it, it's actually float. Okay, there we go. There's our target rotation. The next thing is we want to have our turn sensitivity. And sometimes what I look at when it comes to turn sensitivity is how far I want to look, almost like an offset, if you will, or almost like a buffer, right? And I call that, turn sensitivity. So again, we can say that that is our turn sensitivity, right? Kind of gives us our smoothing value, if you will. We're going to maybe get rid of that. And then we're going to say if my absolute value of our target rotation, whatever the target rotation is, right? If the absolute value of that is greater than the turn sensitivity, right? So again, greater than 5 degrees. So if we have to move more than 5 degrees, if it's less than 5 degrees, keep going straight. If it's less than 5 degrees, then, or greater than 5 degrees, then now we have to turn. And then if the target rotation is greater than 0, so a positive turn, then what we want to do is we want to set the current direction, or sorry, set the current heading, which is, remember, it also sets the direction, to the current heading, get current heading, again, is an angle. Heading is an angle, direction is a vector. And then we add to it the get, or whatever the turn rate is. Okay, so that's what that is. If, however, else if our target rotation, right, is less than 0.0, if it's equal to 0, we don't care about it, right? Then what we want to say is that let's set the current heading to our get current heading, whatever the angle is, minus the get turn rate. So that way it's going to go to the other side, left, turn left instead of right. So again, positive angles are to the right, so right turn. Negative angles are to the left, left turn. Okay, and really depends on the sign of the angle that we get. Let's make these into consts. And now, because we change our current heading, we don't do current direction. Current direction is not something that we want. In fact, but we do want this. We want our acceleration to be influenced by the current direction, not the current heading. So here, instead of this instant changing of our steering direction, again, if you think about it, is a Vec2 object. And we're looking for a Vec2 object, our target direction. This is where we want to go, right? So we can dispense with this, and we can put in look where you're going and pass in the steering direction. And this should be better in terms of how fast we change, we move, how far we move, or how much we rotate. Okay, let's see how that looks. Does it work? Is it bugged? You know, how does it go? But this is my thoughts. All right, so we'll bring up the thing and we'll toggle seek, and all right, that's more like it. That's more like it. Okay, let's stop it and reset. Let's return those values a little bit lower. So we'll say that the top end speed is 10. We'll drop this speed to 2 so we can see the difference. We'll see the turn rate as 5. What if we made the turn rate something like we can turn only 2 of an angle every single time, right? And if I did that and started off, you can see that it kind of goes in there and then overshoots and overshoots and overshoots. Now the last piece of this is, because this is exactly what we want to do, notice that it's just going to keep going because we have some acceleration. And if I increase the turn rate, right, what it does is it allows me to turn quicker, right? If I decrease the turn rate, so it kind of goes like 1 degree, you know, or whatever, then yeah, we're going to be like pretty much right there. So this is pretty cool. I like how it works. The only thing that's left is to turn our ship so it looks like it's pointing in the right direction, right? And we need to get an angle. So when we're drawing our image, right? When we're drawing our image, then what we can do here, where it says get current heading, we can use that right here. So instead of making it a 0 angle, we'll change the direction that we're drawing everything to here, get current heading. And this will adjust the angle of our ship as we're moving. Let's see if that makes any sense. Does it look good? Yes or no? So again, open that up. If we toggle seek, we're going to see that it kind of works in that direction now. And it's pretty cool. Again, really fast. Let's stop it and reset it. Let's move it really much lower. And now we can consider whether we want to kind of do what we did before. Look at that. So that's kind of slow. Turn around, turns around, because we made the acceleration so low, right? And that's pretty low. So that's, now you can see where we took away, I always take away and put these back, this delta time stuff. And the reason for it is because it needs time to be implemented. Let's start off with velocity. Let's multiply velocity by delta time and leave delta time away from acceleration. Let's see what that does. Remember, velocity gets scaled, right? And again, if I turn that on, what does velocity scaling do, right? It kind of makes it give me a bit of jitter, and it does that kind of stuff, right? That's what it does. What about if I increase my acceleration now? So let's say increase it to something like 10 and then turn it on, right? Again, you can see that it turns pretty quick, right? When I use this thing right here, right? It turns one way and turns the other way, right? I can increase my maximum speed. So let's say I go to 10, 50, 53 or something like that. And if I increase my acceleration at the same time and I increase my angle, so my turn rate is like way more, like 11 degrees. This is 11 degrees every frame. If I bring it down, right, let's say to something like 2 or 3, then what's going to happen is it's going to take only 3 degrees it can turn, very small rotation. So the smaller the turn rate, right, that's the angular velocity. The angular velocity is low, right? If the angular velocity is lower, it's going to take a lot longer. I'll skim through it, but I won't stop. Take a look. But as I increase the angular velocity, this is what happens, right? It kind of is able to match and, kind of move through here. Not bad, right? Look at that. Like a fish. Kind of looks like, and it's kind of making decisions based on, the way it works, right? So that's pretty cool. We can increase the speed, the acceleration, and really increase the speed to see how that works. And if I decrease some of this, it's going to go, kind of bigger orbits. It'll make bigger orbits. The more I decrease it, the more of the orbit's going to increase because it can't turn fast enough for the speed, right? If I decrease the acceleration, you're going to see that it kind of wraps right in, right? Not bad. So that is your look where you're going, right? Caution. The bounding box has not been rotated. The bounding area has not been rotated. So that's the next thing we're going to do. How do we rotate the bounding area? And if we do, right, if we change the bounding area, what we want to do is there's two ways to change the bounding area when we do rotations, right? And one way to do it is again, if you change the bounding area so that the rotation changes along with it. Let me explain. So this is pretty good, actually. Let's put this up on GitHub because we've kind of come to a point where I'm pretty comfortable at this point about what we've done. So pretty nice. Let's put this up on GitHub. So again, I'm going to bring up GitHub Desktop, and we'll say something like added look where you're going, right? Commit to main, and I want to push this up. Okay. Nice, excellent, right? So that's what that was about. But what I'm talking about is something else. So again, going back to this, we kind of was able to do this now. We use this equation, and that's nice. But what I'm talking about is when we add the ship. So let's grab that ship, and we can grab that ship from the assets. So if I want to go to the assets, I want to open up the folder in File Explorer. This is kind of a quick way of doing that. And what I want to do is I want to grab that texture, which is the Ncl texture, and I want to talk about it a little bit and how this is challenging for us to use. So I copy that, and I go here and I paste it. And it, of course, didn't work. Let's open it up. So if I, yeah, there's this one right here. So I want to save the change to the document. No, I think we're good. So here's our Ncl, and this is what I want to kind of talk about. But maybe we can do it in another program, something that's not the whiteboard. I kind of think about that as the whiteboard. Let's use, instead of that, let's use our fireworks for a second. And I want to talk about it here. I find that different drawing programs allow for different things. So I want to talk about that right now. So there's our Ncl, and let's suppose I have a screen size, let's do that too, of 800 by 600. There we go, perfect. Then I have a white background, and I'm going to take our little Ncl, cut it out of here, and put it over here, right? And we talked about how we can spin around. Let's see if we actually have the target too. We might have the target. If not, I'll just copy paste it from inside of our game again. One sec. Let's open that up. So this creates another problem, is what I'm trying to tell you, right? So, and here, circle target. Just to be super accurate. That's why I'm doing this. I meant to do this. And of course, yes, it worked. Okay, so there's our circle. So a circle, this is the exact size now. So imagine I'm starting off over here, and the circle's over here, and I'm rotating, okay? And I want to talk about bounding areas, bounding boxes. So let's make a bounding box, and let's draw the bounding box with nothing in the middle, and we'll make it so that it is green. Nice green area with about 3 border, and we'll kind of draw it around the Ncl, which is our little spaceship. Okay, there it is. Ncl, bounding box drawn. Okay, so that's nice. But as soon as I rotate this thing, and let's suppose I use a rotation to do it, so I do this. Well, the bounding box doesn't make any sense anymore. The bounding box still looks like this. If I'm pointing there, and this is my ship, let's say, the bounding area looks like this, but the actual object looks like this. So what we should do, if you want to keep AABB type collision detection, right, which is, and we want to be accurate, because what's going to happen is only this part is going to collide with this thing here, right? If you want to be more accurate, then the right thing to do is reset the bounding area to the extents. So we're going to move this here. We're going to move this down here. And that's what we want the new bounding area to be. So every time it turns, this bounding box is going to change. And let's just make it more accurate, like this. That's what it should be. Okay, that's the bounding area. Okay, that's good. That's good. So why am I talking about this? Because this is a collision shape, my friends. And the collision shape is something that we're going to have to decide to apply to the object. Right now, there isn't a collision shape for the object, but we want to talk about the extents. The top left corner, right, as an example of the object, and the bottom right corner are the extents. And we want to draw a rectangle around there, and that is going to be our bounding area. Okay, otherwise, if we're angled like this and we kind of try and do something else, let's see another option. Let's suppose I angle myself, right? And what if I could angle the bounding area too, right? Some of you may have thought that when you're watching this. You're like, hey, why don't you just do this, as an example, or rotate everything together. So when I rotate this, then what I'm really doing, well, is I'm rotating the whole thing like this, right? Yeah, but now we're not doing AABB type collision detection anymore. When I rotate this, and if I rotate the bounding area, it's not axis aligned anymore. And that kind of goes out of scope of what we're talking about in this course. It's nice if we can do something like this, that's great. But that would be an issue. If the object was more circular, then the best solution would be for us to use a circle, because it doesn't matter about our orientation. Orientation for a circle is irrelevant, right? If I rotate or not, it's not a big issue. But this is a problem if we try and rotate the bounding area. So how do we do collision detection? We talked about this briefly last week, all right? And we kind of talked about the collision manager. So here's our collision manager, right? And we have some collision detection tools. We have AABB. We talked about how AABB is kind of okay, but we modified it a little bit, go to definition. And what we did was we said, okay, right? Well, what if it's centered? We'll do something. If it's not centered, we'll do something else. And what we did was we took our objects and we said, okay, A object, cool, get width and the height, and that's your, top left and bottom right. But what is this get width and height anyway, right? Get width and height is something that we set in the object. So if I was to look at the spaceship, going back to my spaceship example, and let's close down all the other stuff that we don't need because it's just polluted. Actually, let's just close everything down, reopen our spaceship. How about that? Close all tabs, and we'll save everything, and we'll open up the spaceship just for a second and talk about, positives and negatives of this thing. Okay, so there's our spaceship. Well, look what we do. We set the width and the height based on the texture size, right? The texture size. And when we report on the width and the height, right, as an example, and if I want to report on it every time I'm moving, right, as an example, will the width change, right? So will my texture size, this size value, will it change if I rotate my ship? That's something you should check, right? So let's see what happens. So going back to my spaceship, I'm going to do rotations with Look Where You're Going, right? And what I want to do is this exact thing. I want to be able to go, hey, Texture Manager, let's get that size. I want to get the size happening. Okay, this is important to try and figure out here. So say, hey, Texture Manager, when I'm moving, get the size of my spaceship right now because we're moving around. I want to see what the texture size is. Does the texture size change when I rotate stuff? Yes or not? If it does change, if the texture size changes in memory, right? Because I'm holding it in memory and I'm rotating it, can I somehow redo the extents, right? Because then I'll know what the bounding area will be when I rotate the object. Well, let's see. So we'll say that we'll call this size, right? Which is width and height. So we'll start off with the width, right? And we'll put it in something like this, width, just to make it interesting. And then we'll drop in the size dot x, and then followed by a comma and height, and then followed by size dot y. That's how we do it, size x and size y. Nice, nice. And then let's close it up. And then put an end line, right? So that is what we want to do. So every time we're calling this look where you're going function, we're going to see if the size changes. Does it change? We're polling the texture from the texture manager every single time. So we modify stuff, we rotate, and when we rotate, we're also rotating it here in the draw function. We're calling the rotate function here. And this draw function in the texture manager, let's go to definition, right? The draw function in the texture manager, what it does is it says, okay, cool, query the texture, right? As an example, that's what the draw does. And then down in here where we do a render copy X, this is where we get the angle. And so we're actually copying the texture back onto the renderer. So here's the renderer every single time, and we're getting a copy of the texture and we're sending it into the renderer. We're changing the angle. So if I was going to predict what the draw function would do for us when we're rotating, we're not actually rotating the texture. We're just copying the texture differently here. So my guess would be that most likely the destination rect is something that we're going to have to get access to somehow. And so this is looking at the draw function because that's where we're actually doing the work. But let's see if I'm right. So if I run it, we're looking for that one thing in the here. And if I press, play and just watch the numbers come out, does the size change? Does the size change? Never. It always stays the same, which is what I thought it would do. And so now we have a bit of a problem. We don't know what the size is going to do, right? So even though we do this get current heading thing and it changes, we, trying to find a bounding area for our object, right? Because Texture Manager doesn't really know what that thing is, that doesn't really help. Let's see if we can do it in the draw function instead. Maybe we can get some information, somewhere else in the draw function, because, we can also look it up on in SDL and see if we can do that. Because here's what we're doing. We're querying the texture. That's what's happening. Every time we draw it, we query the texture. We're saying, hey, get the texture from the texture map. Cool, right? And the query texture function gets the texture, the format, and the width and the height. Texture width, texture height. That's what we do. And then I have my source rect and destination rect, and that's all equal to the same thing. Source and destination is the exact same thing. Where does angle come in? Because angle, that double angle, is when we're actually going to do, we're going to redraw the texture every single time, right? And so here it says when we render copy X, it says we're drawing the texture. And the texture itself is the source texture, and the destination texture, right? So a pointer to the source rectangle or null for the entire texture, and a pointer to the destination rectangle or null for the entire rendering target. So we have a source and destination, and the texture itself. This is the actual texture itself. So this is the actual texture that's being stored. We have a source and a destination. And we're not rotating it here at all. Here, same thing. Our query texture, as an example, if I rotate the texture, it's one thing, but it's still going to be the width and the height that we kind of decided on, right? So what about this destination X and Y, right? What is it? that's the width and height of the texture. Let's print that out. And it's going to be a lot of printing, but it's okay because we can also do a breakpoint, but that's a little bit worse in some ways. All right, so we're going to get the width and height of the destination texture. Let's run that thing and see what's happening. Now this will always print, whether I'm rotated or not. Okay, so there it is. Width and height is 480 and 80. 480 is the width, 80 is the height. Okay, cool. Let's run it. And let's see what happens when I toggle it. Hey, that's good. That's really good, right? Look at how the width and height changes. It starts off of 480/80, but then what happens is it modifies the height and the width based on what's happening. These values change to some degree. Okay, to some degree. It becomes wider in some ways and slimmer in other ways. So it does modify when I'm moving it. But one thing to note, if I just pause for a second, and let's go back to that texture manager just for a second. So texture manager. When you're pausing, you have some additional information sometimes. So if I hover over, as an example, you can try and figure out what the values of these things are. So again, I want to hover over and get these values. You can see what they are. Down in here, you have autos. And again, I can look at all the objects that I'm keeping track of, delta time as an example, and a bunch of other stuff, my mouse position, current scene, and la la la, right? I also have my locals here, right? So, and wherever I'm clicking, it's context sensitive. Here's my output, right, that we talked about before. Any errors that I have, there's some warnings. You got to be careful of these warnings. These warnings mean something, right? So it'll tell us if it's something that's uninitialized. It'll say some stuff that's uninitialized, but sometimes that's beyond our control. It's something that's somewhere else. Okay, so local variable, it says uninitialized in the texture manager, and it'll actually take us to every double click. It'll take us there, right? So we say that source rect and so on. So that's the draw function. And so we know something's happening with the destination rect. We know, right? We get the source rect and the destination rect, and that number is fluctuating. But is it fluctuating enough? Right? Is it fluctuating enough? So, for example, if I rotate my texture, and let's go back to the example, say I rotate my texture, and I don't want to start here, so I'm not drawing anything. You can see right now it's kind of reporting back about drawing my texture, but what is this drawing? What is this thing drawing? Is it drawing this 480 and 80? What is 480 and 80? 480 width. That's this much, right? And 80 height. That's this much. Okay, 480 width and 80 height. Why? Because if I move it around, and let's suppose I move this over here, now my width is 689 and my height is still 80. That's this thing. And if I move this down, you can see that my height now becomes bigger. I need all this as height. So really, the destination rectangle, this thing here, is useless to us because this is the destination surface we're drawing to. The larger the the object, the destination surface is going to be what we're doing with it. Source rect, right? Source rect is our source rectangle. We start off with 0, and we have our texture width and height. And what we're going to do is we're going to calculate the texture width and height from the texture map. That's what's happening. That's when we're querying the texture. All right. So that's what query texture does, source width and height. And let's change this to source. So source rect. And the same thing goes with source rect.y. Okay. And so those two things are, kind of neat. They might tell us something else. Let's see. Probably not. Source and destination. All right, again, this is going to print every single time. You can see that it's 0, 0, source rect. And it doesn't matter if we move this or not. That never changes. It's always 0, 0. Okay? And even if we enable this one, it doesn't really matter. Again, always 0, 0. So why is it 0, 0? Because that is the origin. The origin of our object becomes our source rect. Source rect. Okay, it's equal to the texture width and the texture height. Okay, how about the texture width and the texture height? Let's try that. So texture, just to get an idea of what this does. Here's texture width, and here's texture height. Nice. Texture width, texture height. And let's look at that. Again, this is all in the drawing. So 40 and 40, that's the thing that's been drawn. Okay, nice, nice. But what happens when I start drawing this? You're going to get both, right? You're going to get one that's 101 and 54, and another one that's 40, 40, and those numbers are never going to change. That's what those numbers are. For each one, you get a width and a height. 40, 40 is the target. 101 and 54 is the other one. Okay, so the next step is, let's look it up on STL. Is there something on STL that allows to detect the rotated texture? So rotated texture bounds STL. We want to know what the rotated texture bounds. So it says, here's a view topic on libs STL, a method to rotate a texture on the forums. And we can see that this goes back to 2014. And it says that, hey, we can certainly rotate a texture. Here's my rotation. I take my STL renderer and I give a float angle. And then it says the STL texture target is I'm going to create a texture. So what this does is it actually creates a texture in memory. And then what I'm doing is I'm render copying X from the texture we're creating based on, we're going to use the current renderer, the pixel format, and we're changing the width and the height. Whatever that width and height is where we're going to store our data. And we're going to copy from, we're going to set the render target to the renderer, and we're going to, do the thing. And it says, however, it doesn't quite work. Transparency is lost, and it becomes black. And it says, as for one, you need blending. And it says, as for two, consider the source rectangle center point and the origin and 4 vectors pointing to the 4 vertices. These 4 points will always be the further away points from the center. So if you make sure that they're inside the texture after rotating it, you're good. Okay, so this is what they're talking about. And it says that when we rotate a texture, what we're actually doing, we can use some math. And what we're actually doing is rotating points. Okay, now we're on to something. So what that means is, if I look at the center point for this thing, let's suppose that the center point is approximately right there. So let's just draw a little point to give you a sense of what that means. So let's say I draw a little point that's right here. This is our center. Maybe not our center. We can actually find our center by just drawing lines like so. Try another one. So our center is more like over here. Okay, that's our center. So when we rotate 4 vertices, right? So we have our 4 verts. So we have, let's say we have a vertice that's A, and let's make that a lot smaller than this. So we'll go down to something like 20. There we go. So we have 4 verts. We have this one. We have this one. This is B. And we have this one, which is C. And we have another one. Which is D. So what we could do is we could, create a rotation for each of these points. If we find out what these points are, when we rotate the object, right? Then what we want to do is we want to rotate these points, and then we can create what I talked about before. So let's rotate the whole thing. Let's align this and let's group. We can actually do a grouping. So it becomes like one object. This is nice. And then what I want to do is I want to rotate these things. And so these points are also rotated. This rotates there, this rotates there. And what we want to find is the extents. So we want to put all these 4 points inside of some kind of, once we know what they are, these points, we put them inside of an array, and we can sort them for min-max. We know that this is the minimum point on the x-axis, right? And we know this is the maximum point on the x-axis over here. We know that this is the maximum point. Actually, because we're drawing down, that would be the minimum point of the y-axis, and this would be the maximum point of the y-axis. Once we know these things, we know what this is. We have the minimum and the minimum here. That's the top left corner. That's this one right here. And we know the maximum and the maximum down here, which is the bottom right corner. We can now draw a bounding area. That's how it would work if we were going to do something like that. Okay. But the math to rotate the points around a center point. The center point, if it's, and all of our objects are centered, that would be the trick. And so we won't do it this week, but what I'll do is I'll come up with a utility to rotate, first of all, to get the points from a vector, the extents. And when I perform a rotation of X number of degrees, it's going to return out an array of points, or basically two things: the two vectors, the top left and the bottom right. That's the function I'm going to create, because once we have the top left and the bottom right, after we rotate an object, right, even if the texture stays in memory and it's still this, right, the new points will describe the bounding area. And once we have the bounding area for those points, then we can do proper collision detection with this area right here. All right, let's finish off this thing to make sure that we've covered everything that Alex wanted us to do. So we can change the inheritance. We did all this part. We added getters and setters. We did this part. We set the target as Starship target and the target as an agent. Yes. We set the target to be disabled upon start. We did that. We added a checkbox to enable the Starship. We did that. We added behavior to seek and move. We did that. Fill in the getters and headers. We did fix the boolean for IM GUI. We did that. Add slider for maximum speed. We did that and more. And now the last part is add collision check in the update function. And the one thing he wants to do is load a sound for the collision and add look where I'm going, look where you're going to the Starship, and reset button to IM GUI to restart seek. We did this already. The only thing we're missing is this and this. So we'll do a preliminary, detection. We'll do, and the other thing we can do is we can also use a distance check. Remember we talked about that. The distance check is also something we can do, or a circle check. But we're going to choose AABB, AABB. It's not going to be fully accurate, but we're going to be better than we were before. It's because our ship is irregularly shaped, and that's an issue. All right, so let's go back and do that. So how do we make sounds? Well, the sound manager has a bunch of things we can use to make sounds. We can play music, we can stop music, we can load a sound type, and so on. And the sound manager itself is the thing that has most of the controls to do everything we need to do. Okay. So we want to be able to play whatever we're going to play. And I had some examples of that in the collision manager already. Let's take a look at the collision manager and see if we get some examples of that. And so here's one: sound manager instance play sound yay, the yay sound when we do a squared radius check. Squared radius check is like we're going to do a circle check. Okay, again, not fully accurate, but in this case, maybe more accurate than using a bounding box. Let's describe that again. So if I go back to here, what if? So let's undo. And we don't use a bounding box for this. When we talked about that the area is significant, right? So this area here, we made it a bounding area, but what if we made it a circle? We talked about all this as well, and we said, making it a something other than a circle or other than a square or bounding box is going to produce visual errors. But we're going to have tons of visual errors now because the bounding area, unfortunately, for this object, right? And let's just move this so it's a little bigger. The bounding area for this object, well, it's going to rotate, and we have no way of rotating it cleanly right now. We will, but this isn't bad. And the reason why is because if this rotates, let's do a grouping. So this is what's going to happen. When we rotate this thing, well, the circle isn't going to rotate, but the top of the thing is going to have that little bounding area, which is pretty cool, right? Look at that. So the front of this thing, because it's front loaded, it's going to go into the front. It's going to work pretty good because it's moving, and the front area, which is going to collide with this one, it's actually going to look okay if we did it this way, right? Because we're not caring about this side, and we don't care about this side right now. We only care about this part. Okay, just FYI. The other thing we can also do is we could draw a line, right? A line segment in front of the ship. We can draw separate line segments, and then we can rotate those line segments. So actually draw a rectangle and rotate the rectangle, like actually do a rotation algorithm on the rectangle or the line segments, and then we can do line, circle, collision detection, that kind of stuff, right? Which isn't a bad thing to do either. But this isn't bad. So we can, if we rotate, we're going to put a circle around this one. We're going to put a circle around this one. So they're both going to be circle, circle. And we can do something that's less computationally expensive, which is to use something called squared radius check. Yay, right? And we can say that in case the first object is going to be the ship, and the second object is going to be the target, it's kind of ready to go. Look, sound manager instance play sound, yay. But somewhere in our code, we have to load the yay sound. Yay sound is actually something that exists. If you actually go to solution, and if you go to, if we open this thing up as an example in our file explorer, and we look inside of our assets, and we look inside of audio, then you can see that there is a yay.og sound that will play, right? Yay.og. It's going to go yay really loudly, actually. So this is good. So we're ready to go with this thing. All we need to do is use it. So we can say collision manager, squared radius check, spaceship, and target. And if it's the target, make a sound, but we don't have this sound loaded. So that's something we need to do. Let's do that. So again, going into the scene itself, which is the play scene. So scenes, play scene.cpp. Then we can, up here where we did all these draws, this is pretty cool. We can turn on the bounding box or the circles for these things. We did bounding areas, rectangles. We also drew a circle if we want to for the the target, right? And we can certainly draw a circle if we want for the spaceship, right? And that's pretty simple to do, because if I were to draw the target for the circle, let's draw it, and we can draw a target for the spaceship. So draw circle. And again, it's going to be the center, M_P spaceship, easy to do. And get transform dot position. And it's acting weird, but that's okay. So get transform dot position. And then for our radius, right, how big it is, we want to get either the maximum of either the width or the height. We don't know which one. So we can do that. We can say, I want the max of, right? And I want to do util max. And where I want to take two floats, a width and a height. So I want to say M_P spaceship, right? And then we want to get width and M_P spaceship. Get height. I don't know what happened to my code ending. It turned off. Right? Pretty good. That is going to be the min, and that's going to be the max of either the width or the height. That's what it's going to do, right? And what else do we need for a draw circle? Radius and color. Color is going to be green. It's no problem. And so that is what's going to draw stuff. And we only want to draw this if it's enabled. So we can say if m_p spaceship, right? And then is enabled. If it's enabled, then and only then do we want to draw the circle. Otherwise, we don't. So again, when we run this thing, let's see what that looks like. So we can visualize first. So certainly we see the, we can get rid of that. We see this, and when we turn the spaceship on, and let's make the acceleration 0 and the max speed 0. We just want to see the ship. And there it is. Okay. That is pretty big, width and height, so that should be smaller than that. Let's try that again. And why? Because we want the width and the height, but we want half the width and half the height. So let's say 0.5 here, and the height is 0.5 there. And this is going to give us a sense of what the bounding area is going to be like as well. Let's run it again. Again, what I want to do is just turn all these down. So make it so that this is 0, 0, 0. So 0, 0, 0. Let's look at that ship, and you can see it kind of bounds this and bounds that. And then when this turns, it's going to be here. So that is what it's going to look like. Wouldn't it be nice if we can turn off and on that debug view, right, by clicking a checkbox, right? So we can kind of turn that on. So this is target. And before the target, we can add some additional things. So we can say that, what if, let's add another separator up here. And we'll take this checkbox. And we'll rename it. We'll say that this will be toggle debug. And we'll say toggle debug debug draw. Actually, we just say toggle debug so we can see what that looks like. And we're going to say that by default it's false. Okay. And when it's true, then we're going to say that debug is on, right? Toggle debug, but debug is on. We don't have a debug view, so we're going to go into our placing.h and add one in. So in our placing.h, we're going to put another thing in. And we're going to call this the debug Boolean, right? So this is going to be a Boolean, which is m_b. And if we tried to make this the one, toggle debug or whatever, debug view. So my debug view, again, remember we're in my placing.cpp. In the top, I can always set up my, it goes to my start, go to definition. And I can say that my title is this, and by default, my m_b debug view is false. So I'm going to say that that's false. It's off. And then what we can do is up at the top, right? We can say that the only time we want to draw this stuff at all, we can surround it by if m_b debug view is true. Okay, we'll grab this stuff here. So we can do a debug view if we need to. We'll get rid of all this. This is kind of already inside of our GitHub. Okay, there's our debug view. And then what we can do is down here, we can say that debug view m_b debug view is equal to toggle debug. There we go. And this is cool. M underscore B debug view, and it says expression must be modifiable. L value cannot assign to read only type bool constant. See, this is bool. So how do we fix this? How do we adjust the thing? Because this is a debug, a static debug. Well, one thing to note is, wouldn't it be nice if we just had one value instead of doing this? So we can do that by removing the constant. Let's get rid of that constant, right? And once we get rid of that constant value, then if I go back up to my placing.h, inside of my GUI function, we can take away that constant, right? So constant is what it was, and now we're good. Because it's the placing GUI function was a constant function, and now this is okay. So if I was to run this thing now by default, we're going to see that my debug view is off. So no debug view, but as soon as I go here and I see toggle debug, I can turn it back on. And if I was to turn these things down to 0, show the ship, I can turn on and off the debug view, which is pretty cool. All right, so that works. That's great. So that's what I need to see. Next, we want to do that collision detection. So collision manager was done here. We did a circle AABB check. Now we're just going to do a circle check, which is going to be a squared distance check. So again, if I go back to my collision manager, you can see that we have a squared radius check. That's what I want to do. So I want to do this. And I want to do that here. So I said, hey, collision manager, I want to pass in the first object, which is my starship, M underscore P starship or spaceship, right? And the second object is M underscore P target, M underscore P target. So that is the square radius check. And square radius check is more efficient than distance check. That's cool. And now we just need to load the sound. We just need to load the sound. So there's a couple things here to note, right? So take a look at the plain.cpp. Plain.cpp, all right, doesn't load a sound, right? We need to load something like that here. And I may have an example of something that has a sound in it. Here's the example right here. So in our obstacle.cpp, we have a sound manager right here where we say something like, hey, sound manager, I want to instance load the yay sound. We just need to do that once. So here's where we're going to do it. And I'm going to lift this code from the obstacle.cpp and put it inside of my, it could be on the plane or circle or somewhere, but the target or the spaceship or whatever you want. Let's put it in terms of the target. So target, hey target, let's load you up with some kind of thing that looks like this. And we can include soundmanager.h inside of the target, right? And sound manager, so both sound manager and sound type. And I'm not sure if you need both. Let's see, I need both. No, I think I only need sound manager. And once I load the sound manager, I can say it's going to go into assets audio yay.og, and we're just going to load it up as a sound effect. That's all it's going to be. That's the load sound. So we're going to load the yay sound. Load the yay sound. And we're going to do that one place, just in one object. And now, if we test it, we should be able to hear that yay sound when it touches the target. Okay, so if it does. Let's get rid of that too. That's inside of the texture manager. And that's really annoying to always print this out. That was our debug for what that looks like, because we're trying to find a quick and dirty way of doing this, right? And let's try that out and see what happens. And run it. And let's toggle seek. And if it touches it, we should get a yay sound. And you should be able to hear it. It's really annoying. Let's reset. Let's reset. And again. Right? Yeah, it sounds like really enthusiastic. Let's take a look and see how that looks. So it kind of goes in, touches, touches.
It's
not 100% accurate because there we go. But not bad. Not bad. Not bad at all. All right. Pretty cool. That's all right. Let's put this up on GitHub, and we'll have everything that Alex needs for us for our stuff. So we'll say, cool, we added collision detection and debug view, which is something we added in. Commit to main, and we're going to push. And my friends, that's it for today. And I know that there's not many people watching. It's only a couple people, but from YouTube, do we have any questions? Do we have any questions from YouTube? And I'll wait a second because I know we're behind 1 or 2 seconds, and I'll see what people say when they get that question. And it looks like there's no questions. Cool. Well, thank you very much for watching. Hopefully that kind of solidifies everything that you need. And I will see you guys all on Tuesday for the next lecture. And we'll use this as a starting point for everything we're doing, even for the other people that I wasn't able to complete things for earlier today. I will update our starter with this. Okay. And let's move on for the day. And then we'll talk about that other, thing, this other problem. Can I rotate the bounding area? Can I do that? How do I rotate my corners around a center point? Is that really efficient? Do I want to do that? And what's involved? Talk about that. All right. Otherwise, that's it for me, guys. And so take care, and I'll see you guys next Tuesday. Thank you.